You're in a group chat. 3 messages arrive in quick succession. You can see them land, one after another. You read them top to bottom, and the conversation makes no sense. Someone is answering a question before it's been asked. Someone else is laughing at something that won't appear until 2 messages later. You scroll, reread, piece it together, and realize the messages came through in the wrong order. Every word arrived. Every character is there. Nothing was lost in transit. The sequence got scrambled, and that alone was enough to make the whole exchange unreadable. This isn't just a quirk of chat apps, and it points to something worth stopping on. Getting data from one place to another, and getting it there in the right order, are not the same thing. They are separate properties. A network can accomplish one without the other. Most of the internet, at its foundation, does exactly that. It moves data without making any promises about sequence. And understanding what that means, and what it costs to fix, is what this video is about. Here's an analogy that will carry us through. Imagine mailing someone a book, but instead of shipping it intact, you tear out every page and send each one in its own envelope. 400 envelopes, 400 pages. The recipient gets all of them. Nothing is missing. But the postal system delivered them in whatever order it happened to deliver them. Some routes ran faster, some batches were sorted differently, some envelopes passed through a facility that was backed up that morning. The recipient opens them and finds page 312, then page 7, then page 189, then page 4. Every page is present. The book cannot be read. That is the ordering problem. And it maps almost precisely onto what happens with data moving across a network. When information travels across the internet, it doesn't travel as a single unbroken stream. It gets broken into pieces, packets, each one a chunk of the whole, sent individually into the network. The network's job is to move each packet toward its destination, but it doesn't treat those packets as a sequence. It treats them as independent units. Each one finds its own path. Each path has its own length, its own traffic, its own delays. A router that's handling a surge of traffic in one direction might push some packets along an alternate route. That route might be slightly longer or slightly slower. The result is that packets sent in order don't reliably arrive in order. Packet 3 might land before packet 2. Packet 7 might land before packets 4, 5, and 6. The data gets there. The original sequence does not. This isn't a defect, exactly. It's a consequence of how the internet was built. The network was designed to be resilient, to find a route even when parts of the infrastructure are down, to adapt to changing conditions, to keep data moving, even when the direct path isn't available. That adaptability is what makes global communication at scale. But adaptability requires independence. Packets have to be free to take different paths, and when they do, they arrive at different times. Order becomes a casualty of flexibility. So if order matters, and often it does, it has to be added on top. Return to the book. The fix is obvious once you see the problem clearly. Before tearing out the pages, you number them. Now when the recipient opens them, in whatever jumbled order they arrive, sorting is possible. The paths didn't change, the delays didn't change, but now there's enough information to reconstruct what was originally sent. Networks use this mechanism. A sender assigns each packet a sequence number before sending it. The receiver uses those numbers to reassemble the pieces in the correct order, regardless of arrival sequence. Packets that arrive ahead of their turn get held. They wait while the earlier, missing packets catch up. When the sequence is restored, the assembled data gets handed off to whatever is waiting for it. The network underneath doesn't preserve order. The layer running on top of it reconstructs order from the numbered pieces. This distinction between the network that moves and the layer that orders matters because ordering is not free. It costs something. When a packet arrives out of sequence, the receiver has to wait. The data is present, but it can't move forward until the gap is filled. For some applications, that wait is tolerable. A file download doesn't care about latency. You just want the complete file assembled correctly. A database transaction must arrive in sequence or the result is wrong. For these cases, holding packets and waiting for order is the right trade-off. The cost of waiting is smaller than the cost of getting it wrong. For other applications, the wait is the problem. A live voice call depends on audio arriving fast enough to sound natural. If one packet goes missing and the receiver freezes, Holding all subsequent audio until that gap is filled, the call becomes unusable. Waiting for the correct sequence costs more than the missing data itself. In those cases, applications sometimes make a deliberate choice. Don't wait. Skip the gap, keep moving, accept a small glitch rather than a frozen stream. The sequence becomes a guideline rather than a hard requirement. What this reveals is that ordering is a design decision. Not every application needs it in the same form, and not every part of the network provides it at all. Whether a given communication needs strict ordering, approximate ordering, or no ordering guarantee shapes which tools get used to carry it, and which trade-offs get made along the way. What you can see now, that isn't obvious when you first look at a network, is that arrival and order are independent. Data can arrive complete and scrambled. It can arrive partial and perfectly sequenced. The two travel separately. The internet, at its base level, promises neither. Everything reliable that runs on top of it earns reliability through deliberate mechanisms, numbering, holding, sorting, waiting, that have to be built, maintained, and paid for in time and complexity. Ordering is one of those mechanisms. And like most things in networking, once you see it clearly, you start noticing its effects everywhere.